Okay, with this application here, we're going to try to discover the effects of altering the three variables a, h, and k when the quadratic function is written in vertex form. Directions say play around with vertex form of a parabola by changing your a, h, or and your k values one at a time and then together, and observe what happens. You can also press play. So the first thing that I want to do is I'm going to reset my A, H, and K back to where it would be the parent function. The parent function would have A as 1, H as 0, and if I can get it there we go, and K as 0. Let's see, the sensitive. So there we go. Right now, it's the parent function. To prove it, I'm going to type in, if I can get it to go, there it is. I'm going to type in y equals x squared. And I'm going to change my color so you can see it's two separate colors. So there's the blue done. So you can see the blue is right on top of the red. So technically, the A is 1 because 1 times anything. It's like not having the 1 there. The H and the K are both 0 because x minus 0 still gives me the x. And adding 0 to the K, still all I'm left with is the x squared. So this down here in blue is the exact same thing as what we have in red to illustrate that the base numbers, the numbers we start with, A is assumed to be 1 in the parent, H is assumed to be 0 in the parent, and K is assumed to be 0 in the parent. So I'm going to turn this off right now. So I'm going to work through each one of the letters. I'm going to start with K because K is the most straightforward. When I slide up and down here, I start to see the impact of changing the K. My parabola simply shifts vertically. Shifts. So that's the vernacular, the terminology we want to use. K, the impact of K. It makes it shift vertically, up and down. Now I do want to bring your attention to something. Oh, what I want to bring your attention to was K is said to be the constant term. And if you look at the form, vertex form, it's similar to slope-intercept. Y equals mx plus b. So the A is kind of like the m. All of this stuff here, x minus a squared, is kind of like the x, and plus b. The K is kind of like the old b, the y-intercept. And again, as I move the K, which was the y-intercept and slope-intercept form, you can see the correlation. All right, so K, it shifts vertically. So now I'm going to put it back to 0. Now I'm going to play with the H. When I slide the H, it makes it shift horizontally. Notice I'm not saying it's shifting on the Y. It won't always be on the Y, but it will always shift horizontally, left and right. Now, second thing I want to bring your attention to is this. I'm going to put it right here. Right now it says H equals 1, and it looks like it went 1 to the right. But if I put this 1 in this equation, it won't look like a positive 1. It'll look like x minus 1. It'll look like the 1 is actually a negative 1. You'll see what I mean, what I'm trying to point out a little later on. I just wanted to bring your attention that when you see the 1 in the equation, it won't look like a positive 1. It'll look like a negative 1. So there's some counterintuitive stuff going on here. So again, when you change the H, the effect is it shifts the graph horizontally. All right, so I'm putting it back to the 0. All right, let's play with the A. Right now, the A is 1. So we're going to do a couple things. We're going to make it larger than 1 and smaller than 1. So first I'll just make it higher than 1. As I get higher and higher from 1, it gets skinnier. What's actually happening is the equation is stretching, or the graph is stretching. It's stretching. So again, I was here at 1. I'll go back to my 1. As I get higher than 1, the further I get from 1, the skinnier or the more it stretches. So it's said to have a vertical stretch. A stretch. Now here's where it gets a little sticky. I'm going to go back to the 1. Now when I go less than 1, just one quick less than 1, notice 0.8, 0.9, 0.7, 0.6, 0.5. Each time I move it closer to 0. So right now I'm at a number between 1 and 0. So the impact as it moves between 1 and 0, it looks like it's falling or it's compressing. So it's getting closer to that x-axis. So we had a vertical stretch, and now we have a compression. So the compression occurs as we got on the other side of 1. Now as I get closer and closer to 0, as soon as I hit 0, there we go, let's get it back to 0. When I get to 0, first thing we notice, there's no more parabola. All we have now is a horizontal line. Let's understand why. If A was 0, that means I would be doing 0 times all of this stuff here, and 0 times all of this would equal 0. Plus K would still give me just the K, but K was 0 also. What I have now is no longer do I have an exponent of 2, because 0 times this stuff gives me 0. No longer is it quadratic. It's now, because it's a horizontal line, it's no longer a quadratic function. It's now a constant function. So we recognize that when A was 1, that was our parent. And as A started to decrease, it got a little flatter. It began to compress until it got to a point where it was no longer a parabola. So now we'll look at the other side. Soon as A becomes negative, what occurred was the entire picture reflected. So if I was at positive 1.4, now negative 1.4, all that occurred, if I can get to it, 1.4, all that occurred is the parabola reflected. So we have a couple things going on with respect to A. All of our conversation speaks about where A is relative to the number 1. So it's either greater than 1 is a stretch, so I'll demonstrate. Greater than 1, it's a stretch. The next benchmark is between 0 and 1. It's a compression. And then negative. Negative makes it reflect. And what we'll notice is this. If I'm at negative 1, all I did was take, let me turn this on. Then you can see the original parabola, all it did was reflect. And the only thing I changed, A was positive 1, now A is negative 1. All I changed was the sign of A. So the point I'm trying to make is, if A is negative, the entire graph reflects. Now I'm going to continue to move it. So now this negative, say 2.3, notice it's still stretching because I went beyond the 1. So negative 2.3, you know what I'm going to do? I'm going to put here 2.3. And then you can compare. So you can see, it stretched. The 2.3 made it stretch. The negative made it reflect. So negative 2.3, you have to look at it in two parts. The sign will let me know which way my parabola points. The number will let me know whether it stretches or it compresses. So those are the experiment or the discovery with the three variables. What I want to do is go ahead and actually try to apply. So here we go. It says write the equation in y equals a times x minus h squared plus k form, which is vertex form. You have to be able to be aware, vertex form. Looks like the parabola has only moved 3 places to the right. So I recognize my a has not changed and the up and down hasn't changed. So the only thing I need to do is put a number here to make it move to the right. The average person first thinks you should do x plus 3 because you think, oh, if it goes to the right, h is 3. But what happens? Let me square it and submit. Notice it doesn't do what you expected. And this was the point I was trying to make earlier. You got to be careful. In this problem, that looks like 3 is positive. But in actuality, it's supposed to be in the form x minus 3. So if I put that minus there, submit, there it goes. Right now, it looks like the h is a negative 3, but it went to the right. So the stuff inside the parentheses has some counterintuitiveness. If you want it to move to the right, you put a minus 3. If you want it to move to the left, you put a plus 3. I'll do one more. Here, it's simply moved down. The variable that makes it move down is the k. So the only thing I need to change is the k to be a minus 4. So I could simply just do x squared minus 4. Let's see what happens. There we go. So this should get you started with respect to finishing up this activity. Because as you continue, it's going to continue to ask you for the different types of versions of changing the a, the x, the h, and the k.